Welcome back to my channel. This is the third video of AWS interview questions. In this video we will cover the 4 important interview questions of AWS load balancer, and in upcoming videos we will see the advanced interview questions, and if there is need to understand the concept in easy way, so we will also do the practical. And the main purpose of this video and channel is to provide you easy answers of interview questions, so you can easily explain in your interview from the perspective of the interview. I have prepared these answers, so let's start the video. So this is part 3 and the question number 3. Okay, so the question is, what is elastic load balancer in AWS? Okay, this is most important or commonly asked many times in the interview to check your knowledge of load balancing. So an elastic load balancer, that is short form ELB, is a service that automatically distributes incoming application traffic across multiple targets such as Amazon EC2 instances, containers, IP addresses, and Lambda functions. This service is a part of Amazon Web Services (AWS) and helps ensure that your application is highly available, scalable, and fault tolerant. Okay, so this is a diagram of elastic load balancer, and it distributes the traffic to multiple targets, instances, for example EC2 instances, containers, or there may be Lambda functions. Okay, so in this way it distributes the traffic. So this is the definition of elastic load balancer. Okay, so the next question is, explain how the elastic load balancer works in AWS. Okay, so there may be chances that to check your knowledge, the interviewer may ask that explain that how the elastic load balancer works. So in easy way we can explain like this. So how the ELB works step by step. First, the client make a request to your application, then the DNS name of your ELB is resolved to an IP address. After that, the ELB receives the client request. After that, ELB checks the health status of the registered targets. Then ELB uses a load balancing algorithm, for example round robin list connections, to select a healthy target. Okay, and after that the request is forwarded to the selected target. Okay, and the target processes the request and sends a response back to the ELB, and the ELB forwards the response back to the client. Okay, so this is how the elastic load balancer works. In very short answer I have prepared, so this is how you can explain in your interview in short. Okay, no need to explain very in detail because there is no time to interviewer to listen all your in detail explanation. Okay, so the first point is client request, then DNS resolution, then request reception. After that it checks the health checks. After that load balancing algorithm, then traffic distribution, response handling, and then response to client. So this is how the elastic load balancer works. After that, the question number 5, that how many types of load balancer in AWS. Okay, so basically there are 3 types of load balancer, that is application load balancer, network load balancer, and classic load balancer. Okay, the application load balancer is a layer 7 load balancer. Okay, that is HTTP and HTTPS traffic it handles. Okay, and it is flexible. After that, network load balancer is layer 4 load balancer. It handles the TLS, TCP, and UDP traffic and static IP. Okay, then classic load balancer. Okay, it's a layer 7 4 and 7 load balancer. It works on both layer, that is layer 4 and layer 7, and it handles HTTP, TCP, SSL traffics. Okay, so the first point, that is what is application load balancer. So the ALB operates at the application layer, that is layer 7 of the OSI model. Then it supports advanced routing and content based routing based on URL, path, or host reader. Okay, after that ALB allows multiple applications to be hosted on a single load balancer with different target groups. It supports features like host based routing, path based routing, and integration with AWS services like AWS Lambda for serverless application. 5th point, ALB is ideal for modern web applications with multiple microservices that requires flexible routing and advanced feature. Here is the diagram of application load balancer, you can see here. Okay, so the point is, it is a layer 7 load balancer, and it supports advanced routing and content based routing based on URL path. Okay, here you can see the URL paths, that is orders, images, registration. Okay, and this is our URL. Okay, ALB deals with the for modern web application with multiple services that require flexible routing and advanced feature. So this is the answer of that, what is application load balancer in simple way. Okay, so the next question is, what is network load balancer? NLB operates at transport layer 4 of the OSI model. It provides ultra high performance and low latency load balancing for TCP and UDP traffic. NLB is designed for extreme performance and scalability, making it suitable for high volume application and microservices architecture. It supports static IP addresses, preserves source IP addresses of client, and handles millions of requests per second. NLB is ideal for application that requires high throughput, low latency, and full TCP UDP support. So this is the network load balancer, diagram of network load balancer. Here is the listener. After that, it distributes the traffic to its group, that is server A group, server B group, or server group C, or we also call it as a target group. Then it health checks is here, then EC2 instances, here is the IP addresses. Okay, so this is how you can explain in these 5 points. Okay, after that, what is classic load balancer? It supports both layer 4 and layer 7 HTTP protocols and TCP protocols. Okay, supports application defined sticky session cookies and allowing users to control session persistent. Unlike ALB, where cookies are managed internally, it can stop and start TLS traffic, re-encrypting it if a self-signed SSL certificate is provided. End-to-end encryption is often needed to meet the compliance standard. In simple word, it can stop and then restart secure internet traffic, making sure it follows the rules for keeping information safe. It can also double check the security certificates that websites provide to make sure they are genuine, adding extra protection. So this is the diagram of classic load balancer. Okay, so the next question is, when to use ALB, NLB and CLB? This is the most important interview question because it is asked many times in the interview. Okay, to check your knowledge, practical knowledge, we can say. Okay, so here we can see when to use the ALB, when to use NLB, and when to use CLB with examples. Okay, so choosing between the different types of elastic load balancer ALB, NLB and CLB depends on your specific application requirements. Okay, and use cases. Here guides on when to use each type, that is when to use application load balancer. So it is used when there is a advanced routing, microservices and containers, there is a WebSockets and HTTP, there is SSL offloading and AWS WAF integration. Okay, so let's see in detail. So advanced routing means your application requires host-based routing or path-based routing to direct the traffic to different target group based on the URL host name. So in this situation, we will use the ALB. After that, microservices and containers. Suppose if you are using a microservices architecture or containerized application which needs sophisticated routing and load balancing at the application layer, then we can use it. After that, WebSocket and HTTPS. If your application needs the support for WebSockets or HTTP/2 to handle the long-lived connection or improved web performance, then we can use this. Okay, also SSL offloading. If you want to offload the SSL TLS termination to the load balancer to reduce the burden on your application server, then also it can be used. After that, AWS WAF integration. You need integrated web application firewall protection for your web application, then also we can use this. Okay, for example, hosting a complex web application with multiple microservices, serving a dynamic web content with different URLs mapped to different backend servers, managing a website with heavy reliance on WebSockets for real-time updates. So the next is when to use the network load balancer. So it is used when there is extreme performance is needed, TCP, UDP, TLS traffic is there, then static IP addresses is there, high availability we have needed, then connection based load balancing is needed, then we can use this network load balancer. For example, if your application needs to handle the millions of requests per second with ultra low latency, then it is used. Okay, and if you need to load balance on non-HTTP traffic such as TCP, UDP or TLS, then also it can be used. After that, if you request static IP addresses for your load balancer to simplify DNS and firewall configuration, then also it can be used. Your application demands high availability and reliability with a fast failover. So for high availability purpose, we need to use network load balancer. Connection based load balancing means you need to route a traffic based on IP protocol data rather than application data. So this is when you have to use the network load balancer. For example, financial trading platforms that requires very low latency and high throughput, online gaming servers where the performance and connection stability are critical, IoT application needing to handle the large volume of devices connection. So in this way we can use the network load balancer. In this situation we have to use the network load balancer. After that, when we have to use the classic load balancer. Okay, so it is used when there is a legacy applications or there is session stickiness we needed, SSL termination we have to use, then it can be used. For example, if you are managing the legacy application that don't require the advanced feature offered by ALB or NLB, then we can use the classic load balancer. Okay, after that, basic load balancing needs means your load balancing needs are simple, such as distributing HTTP or HTTPS or TCP traffic without advanced routing requirement. Then we can use the classic load balancer. Okay, means without advanced routing requirements, in this case we can use it. After that, session stickiness, your application needs session stickiness to bind user sessions to specific backend instances. In this case we can use it. Okay, and after that, you need SSL TLS termination but do not require the advanced feature of ALB, then we can use it. In short, we can use this classic load balancer when there is no need of advanced routing, okay, and advanced feature, then we can use it. Simple, such as distributing HTTP or HTTP traffic, then we can use it. For example, when we can use it when simple web application that only requires the basic HTTP and HTTPS load balancing, in this case we can use it. After that, application where the session persistence is required but advanced routing is not necessary. Okay, and after that, internal application or tools that do not need the complexity and advanced feature of ALB or NLB, so in this case we can use the classic load balancer. Okay, so summary. So when to use ALB, NLB and CLB. In short way, we see that when we have to use the ALB, NLB and CLB. So choose CLB for modern web application, microservices and containerized environments that need advanced routing, WebSocket support and application layer features. Okay, after that, NLB. It is option for NLB for high performance, low latency applications handling TCP, UDP or TLS traffic, especially when static IP addresses are needed. Okay, and when to use CLB? Use CLB for simpler legacy application that requires basic load balancing and SSL termination without the need for advanced feature. So selecting the right load balancer ensures that your applications can scale effectively, maintains high availability and deliver the necessary performance and security features. So this is how you can explain in your interview in easy way. So thank you, subscribe my channel. We will meet in another video with another interview question. Take care, goodbye.